This video was made for integral calculus and my teacher is Pedro Salvador Sanchez. Hi, I'm Luis Moreno from the group 423 and I'm gonna show you how to integrate rational functions using partial fraction decomposition. So first we got this problem and we are gonna do integration by partial fractions. The first thing we're gonna do is to make sure that the integral is completely factored. As you can see on the bottom, we have a difference of perfect squares. And now, what we're gonna do is to turn this expression into this by factoring it. Now, once we get this, to use the technique of partial fraction decomposition, what we're gonna do is to break up this expression into smaller fractions. And so we're gonna have some constant over x plus 2 dx, and then this is another constant on top over x minus 2, like this, dx. Now for this we got to determine the values of a and b for this problem. And now we're gonna set this fraction over here like this. And we're gonna equal to a over x plus 2 plus b over x minus 2. And now if we calculate the value of a and b, then we could use that to find the indefinite integral of these two expressions. What we're gonna do right now is to multiply every term by the denominator on the left side. So that is x plus 2 and x minus 2. So when we are multiplying this fraction, these both factors are cancelled automatically. This one is cancelled and this one is cancelled as well. And as you can see, we're only left with 1 in the left side of the equation. If we take a on this side over x plus 2 and multiply it by x plus 2, then the x plus 2 factors will be cancelling behind a. And this is going to be only a, and this is going to be cancelled. And now this is going to be a multiplying x minus 2. As well, if we take this fraction, this is going to be cancelled with this one. We're gonna left b times x plus 2. And this is going to be written down like this. Plus b times x plus 2. Now, when you have linear factors like x minus 2 and x plus 2, there's a shortcut technique that you could use in order to calculate the value of a and b, and that's it by plugging in numbers in x. If we were to plug in x equals 2, like this, x equals 2, this term becomes 0. So we're gonna have this 1 is equal to a times 2 minus 2 is 0. And this is gonna 1 plus b times 2 plus 2, which is 4. Then we get this 1 is equal to 4b. Then Dividing those both sides by 4, we get that b is equal to 1 over 4. And then, so another value we can try is x equals -2. If we do the same with -2, it is gonna be like, let me do it right here. It's 1 equals to a -2, and so if this is +2, now multiplying -2, this is gonna be 0. Now we get that 1 is equal to -4a. If we do the same, multiplying both sides by -4, we get that a is equal to -1 over 4. So as we get the values of a and b, we're gonna replace those values over this expression right here, and this is gonna be like that. It's gonna be equal to, let me see, this is gonna be -1 over 4 over x plus 2 plus this one. This is gonna be 1 over 4 over x minus 2 dx. And for now, we're gonna take this constant to the front of the equation like this. This is gonna be -1 over 4. Yes. And here is gonna be 1 over x plus 2 dx plus 1 over 4, and this is gonna be 1 over x minus 2 dx. So now we're gonna talk about how we can integrate rational functions. So for doing this, we have to take into account that the antiderivative of 1 over x is equal to ln x, like this. And for this, we have to use the natural value symbol, because we can have a negative value inside a natural log function. So taking into account this one, we're gonna have the antiderivative of these two functions like this. This is gonna be -1 over 4 ln and the natural value of x plus 2. Natural value plus 1 over 4 ln, that is going to be natural value of x plus 2, x minus 2, that's the natural value. So this ln is the abbreviation of natural logarithm. And for this one, we can add the constant of integration, which is c. And the next step is to factor 1 over 4 on this expression, like this. This is 1 over 4 ln absolute value x minus 2 minus ln x plus 2 plus 2 natural value, and this is gonna be multiplied and the constant of integration. One of the properties of the logarithm is that we can convert two logs in a single log, for instance. And taking into account the property of the logarithm, we can rewrite this expression like this. This is going to be equal 1 over 4 ln, and we open here the absolute value. This is going to be x minus 2 over x plus 2. This is going to be the absolute value plus the constant. So this is going to be our final answer. So we can say that the integral of 1 over x squared minus 4 dx is equal to 1 over 4 natural logarithm and the absolute value of x minus 2 x plus 2 and our constant. So this is the final answer for this exercise. And as you can see, that was not the regular substitution method for integration. That was the partial fraction method. So that's a cool method to find the integral. So that's it.